So, welcome back to part two. Those of you that might not have been on the last week, I'm Andy Restalis. I'm the Industrial Control, Safety, and Sensor Product Manager for HESCO. And our guest speaker today, it will be Jim Drew. He is the product or the Industrial Control, Safety, and Sensor special. You don't have your little screen up here, so oh, you do. Automation business manager, definitely focusing in on safety. Jim handles New England and upstate New York. So if you have any issues, problems, both of us are here to help you out. We're going to be diving into the latest safety devices, supporting full technology safety solutions. And with that, I will turn the floor over to Jim.
All right, thanks, Andy. And yeah, as Andy mentioned, this is part two of a discussion and around intelligent devices, and regardless of what implementation of safety you're looking at. So, I mean, the agenda is quite similar to the last installment, if you had been fortunate enough to attend that. And we'll kind of walk through the smart safety philosophy, a briefer dive there, as we did cover it on the last segment. And we'll talk a little bit about the technology itself that we're going to be talking about, which is really CIP-Safety over Ethernet IP. And then we'll zero right in on the product sets, the latest and greatest product solutions that are out there that really put us in that space where we can have fully integrated safety down to the device level. And then we'll wrap up with some tools that allow us to be more effective at what we do. So first of all, the smart safety philosophy and integrated safety. So as you may recall, the last installment was about the smart safety philosophy in general. And we talked a lot about information. We talked a lot about the information enablement of product sets that allow us to get the information into the safety system, but not necessarily tie the safety control itself into that same control system. So in this segment, we're going to talk more about getting it all in one place for those more complex safety applications or larger safety installations. But as a reminder, you know, what we're really trying to do, right? We're trying to move from the old way to the new way, we'll call it. You know, where we're going from the run it till it breaks with, you know, older technologies with no data, no diagnostics to speak of, you know, that results in high downtime issues and silos of information that kind of keep everything from coming together. And we want to get to the place where we do not run it till it breaks. We have excuse me, we have predictive maintenance enhanced diagnostic analytics that provide us information that allow us to prevent things from breaking, keep things running. And that's going to be dependent upon more modern technology platforms with integrated data and diagnostic capabilities with greater visibility, and obviously pulling all that together, improving collaboration across the whole organization and the structures that we do within companies. So, as another reminder here, safety is really the ante, and how we implement safety is going to drive more results in other areas. We can be safe all day, but if we're doing it in, let's say, the old ways, it may not get us the results that we're looking for, right? So if we keep doing things the same way, we're going to get the same result. We need to look at different ways to do things that are going to give us different results and the positive results that we're looking for. So that's where we're heading. And we did talk yesterday about intelligent, simple safety, right? Being information integrated, where we're gathering the information from the safety system, not tying the safety itself into the system, but tying the information from the safety system into the control system. That allows us to make better decisions and have some increased visibility into what's happening with our safety structures. But really, when we talk about fully integrating the safety, we're really talking more about taking advantage of not only the information, but also taking advantage of a much more flexible solution that's much more highly programmable, that allows us to optimize even more and add functionality into our systems that we otherwise could not achieve. And that's really where we start to see the big value in fully integrated safety. Now, having said that, we will state that, you know, every situation is different. Every situation does not lend itself to the let's jump right into fully integrated safety. And that's why we have this two-part series where we talk about the more, you know, simpler safety functions or simpler safety systems that maybe the information enablement is more than sufficient to grab the value that we're looking for out of those installations. But again, where we get into more complex systems or more larger systems with more significant tie-ins and more functionality needs, then that's where fully integrated safety really shines, and that's where we can get the benefits from this. So let's talk a little bit about the technology. And again, we're talking about Ethernet IP CIP-Safety. But before we do, let's just remind ourselves that, as we stated, safety is the ante. The very first thing we always need to make sure is that whatever we are doing is going to be safe. And the question that always comes up in any safety application is, you know, is it good enough? What is good enough? Is it safe enough? And you don't want to be in that situation where you're talking to someone, could be a lawyer, could be your boss, could be an injured person, and they're asking you, you know, why did you do it that way? And if you don't have a good answer for that, you're not going to feel very good about it. So we want to make sure we have that answer to why did we do it this way? Was it safe enough? How do we determine it's safe enough? And the answer to those questions is really driven by this life cycle, right? The answer to the question, why did you do it that way? The best answer that I've ever heard, and what I would submit is the best answer out there went to that question, why did you do it this way? We did a risk assessment per a certain standard, and that drove a functional requirement based on that risk assessment that told us this is what we needed to achieve and how we were going to do it. And then by the standards, and then we designed and verified that, again, to the standards, tying back to the functional requirements that tied to the risk assessment. And then when we installed it, we validated that our physical design did meet the design and requirements driven by the risk assessment. And then we've monitored and improved over time. That's the best answer you're going to get to that question, I would submit. So the safety life cycle is extremely important. Can't say enough about that. And the first piece, obviously, the risk assessment drives the whole thing. So with that, we have, if we go through this risk assessment, functional requirement, design verification, validation, right? We'll have a system. But when we come into the design and verification, that's where we get the choice, right? Well, the functional requirement says that we need to have, let's say, for example, a movable guard with an interlock on it that will shut off that motor or stop motion from occurring or stop rotation on that motor. That's what our functional requirement is. And our functional requirement should also say what performance level of circuit we need, right? So that's what we're gonna do, and it needs to meet the requirement of, for example, let's say a performance level D. Okay, well, now the step 3 is where we have the choice. We can do that many different ways. There are many ways we could implement that solution. And now that's where we come into, do we go fully integrated or not? And those decisions, again, are mainly based on these, the complexity, the flexibility requirements, the other safety functions, if there's a number of them that may need to tie together, right? But step 3 is where we do our design. Now, thinking about these designs, right, looking a little deeper into the integrated solution set, you know, in many systems, this is a good representation of some systems in the reality, the old way, if you will, many systems out there that have this structure, where we have a completely separate safety system up here in the right-hand corner. And we also have, in conjunction with that completely separate safety, we also have some other separate safety activities here managing the motor. And we have a network that we've implemented here with control, and we have a separate network that goes off to some legacy system perhaps In this case, we're showing a device net here and Ethernet here. And what the whole integrated safety solution allows us to do, it allows us to take, first of all, the way we implement the network these days, you can do, linear or device level ring type structures. So you don't really need the star switch in many applications. We may not need that, so we can simplify that way. The relays and safety contactors that may be dropping out those motor loads, we can integrate that into our motor control products, our intelligent motor control products, right? So we can take those and those disappear. That is greatly simplified. And then what we also can do is we can take that separate safety system and integrate that into the controller itself and turn that into what we'll call a GuardLogix controller, where it turns into a red controller, if you will. And all the data and diagnostics, if there were any, on that separate safety system can also be married right into the system. So that separate system goes away. And that legacy network, we can also remove and make one single network across the entire application. And as you see, we greatly simplified the structure of that circuit and added additional functionality along the way. So as you see what popped up there, much more information enabled, fewer components, less training because there's less disparate networks or disparate configuration software, et cetera, to utilize. Streamlined maintenance, everything's on the same network with the same structures and the same software, common software environment for the entire solution. So that's where integrated safety really shines, is taking that disparate technology system and bringing that all into one common place where we can address all the needs in one area. So having said that, usually the next question that people ask is, well, you're talking about Ethernet. Ethernet doesn't sound very safe to me. I have a printer on Ethernet, and when I go to print something, it doesn't always print when I want it to, right? And that's standard Ethernet for printers and such. That's a little different. Ethernet IP is standard Ethernet with additional capabilities set up on the last layer. But at the end of the day, the CIP safety structure is done such that we do get a safe system with Ethernet connectivity. And this slide here shares with you the 3 Ds of safety, and those 3 Ds are utilized in effectively all safety products out there. They're also utilized in the design of safety circuits and safety systems, where we always think about the 3 Ds in order to make sure that we have a robust solution. The first D is duality, right? So in the case of, for example, a typical safety circuit, depending on the structure that you require, but generally speaking, a safety circuit these days, category 3 structure is extremely common. And category 3 structure has 2 channels, right? So you have duality in your data. So you can have one issue and you don't take down the entire safety function. So same idea here, where we have duality. We send the data twice, right? We send the message twice. And when we send it, we have diversity, right? So we don't send the same message the same way. We send the same message 2 different ways. We send it first, standard method, if you will, and the second time we send it, we're going to invert it, right? So we're going to send it 2 different ways. And then we're also going to have some diagnostics involved, right? So we're going to do, well, CRCs, which in my head is really a fancy new way to say a checksum, right? So we're doing CRCs on the data. We're doing it both on the standard data and the inverted data, and we're also doing it on the entire safety message. And we're timestamping it, so we know how old the data is, and we're tying that all together in between nodes. So ultimately, we've captured all the requirements that you really are looking for when you're designing safety systems. And the CIP Safety over Ethernet IP is gone through TÜV certification, et cetera, with all kinds of standard bodies that agree that it is safe and can meet the levels that are required. So just something to take to heart, that CIP Safety is an extremely robust system, but it is also a very safe system. So with that, let's slide into the safety product discussion. There are a number of things to talk about here, but the first thing we'll do is we'll start with just a ground setting again to make sure we're all on the same page that a safety input device does not a safety circuit make, right? We need to have a full safety function in order to realize a safety circuit. And so in this particular case, we touched on this yesterday, a safety function really is driven by typically by the input device, but it can be others, but its most typical implementation, if you will, is a safety device triggering a safety logic device, which then triggers a safety output device. And all three of those pieces need to be present. That is critical. A safety function is only as good as its weakest link, and every link in the chain needs to be appropriately dealt with. When we talk about integrated safety, that is no exception. Effectively, we change some of the verbiage and we change some of the pictures, but the safety function is still equally as important and is just written a little differently, right? Because now when the safety gate is opened, the safety IO is interpreting that signal and managing that in the safety PLC or PAC, programmable automation controller, which is then sending a message, perhaps an Ethernet message, a CIP-Safety over Ethernet message directly to a product, which is what's happening here, a CIP-Safety over Ethernet message directly to a drive. So no safe torque off hardwired from an output card, which is also very doable and in many cases very practical. There are also capabilities to drive that directly over Ethernet. So again, the safety function is written differently, but the concept is the same. So this picture may look familiar if you were on part one. There are numerous products that we're going to cover. But the first section, we covered a bunch of the stuff on the bottom, if you will. And in this section, we're going to cover the products more on the top of the diagram here. So you'll see some input devices here. You obviously have some logic device up on top with the GuardLogix and IO. And then you also see some output devices. So we're going to touch on all three of those as we go through. The first thing to note is that in that diagram, we did not see too many input devices of the size and shape that we typically see on movable guards, et cetera. And that is due to just the nature of the physical size of those switches and the application space that we see. The vast majority of those switches we see as continuing on to be devices that will plug into safety IO of some sort. Could be GuardLink IO, as we touched on the last segment. That is a great way to implement these as well. But generally speaking, just physical size, et cetera, of these devices does not lend themselves to getting integrated safety built in. There is an exception with respect to these contemporary input devices we're looking at here, and that is the multifunction access box. So that is what we're going to start with. We're going to start with the multifunction access box. So first of all, what is a multifunction access box? That's a good question, right? So ultimately, the multifunction access box, if you think about an application where you need access with a movable guard, and in particular full body access, maybe we'll call it a movable door. In its historical implementation, we had a number of separate devices that contributed to that application, right? We had a guard locking switch that held the door closed. We had a separate control station, typically right at that location, that allows us to request entry, do resets, maybe start or stop equipment. And then typically another station, if you will, an e-stop station that was also separately there and mounted near that area for the e-stop. So ultimately what the multifunction access box is, it is a solution set of all those pieces coming together into one product line, right? So as you see on this picture here, we have a door handle version, if you will, of a guard locking switch that interfaces directly with its counterpart piece here that drives the machine control, access control, provides the e-stop function, and all those and sundry things that are needed to make this application work. Also key for full body access, especially with robotic cells, et cetera. Anytime you can get trapped in a cage, if you will, you need to have a escape release mechanism. So it does have an optional escape release. Has multiple lockout points, as you see, auto extending one here on the far right, and a manually extended locking mechanism right on the front, and allows us to, again, pull all those functions into one particular product that we can implement much more readily, much more simply. Now, we also take that same technology, and this is actually the CIP-Safety over Ethernet IP version, where we add additional capability and allow that to occur via Ethernet, CIP-Safety over Ethernet IP, right? So our bus module on the bottom, again, with all the buttons and such that you need. And now you're really looking at a system that utilizes simple connectivity versus standard wiring methods. So again, this switch, ideal for full body access applications. That's really what it's designed to do. It's available in power to release, power to lock, left-hand versions, right-hand versions. It works on either sliding or hinged doors. You do have that optional escape release we talked about. It's an integrated door stop. So the vast majority of guard locking switches out there, specifically in the installation instructions, whether they're Rockwell switches or others, specifically in the installation instructions, it will tell you that this switch is not to be used as a physical stop. This particular product, that is not the case. We can use it as a physical stop because it's really designed to optimize that application. Highest levels of safety, meets all the right requirements out there these days, the most common standards and contemporary standards that are out there. Now the CIP-Safety over Ethernet IP is where the value really comes in with these types of solutions. I mean, one example of that is just the implementation itself, right? So if we have a implementation where we are implementing a standard version, the standard MAB, we call it, multifunction access box, that standard version, depending on what functions you're looking at inside that switch, you will have to land about 24 different signals. And 24 signals is a lot of wiring, and that is something that is easily contributes to miswirings, some troublesome issues potentially if you're an OEM. Many times you have to split ship machines and rewire it in the field. There's just a lot of opportunity to have some issues there. Whereas when we're talking about the CIP-Safety version, you literally plug in some connectors and you're good to go, up to 4, but conceivably based on the application, it may only be 2. It may be an Ethernet connection and a power connection. The way there are 4 connectors because power goes in and out, as well as Ethernet going in and out. So we can daisy chain either one or both should we desire to. But the add-on profile piece here also with the fully descriptive tags, that really allows us to reduce programming time. And we're, again, putting everything on the same network, standard and safety control, safe devices, et cetera. And again, back to the wiring, 83% reduction in wiring is a lot of wiring, right? So we get advanced functionality and advanced diagnostics over that CIP-Safety connection as well. And simplified installation and wiring, just really a lot of capabilities there that come into play. And this is a representation of the add-on profile that if you're familiar with the Logix environment, adding safety devices to your program is like adding any other device in terms of adding it to the tree and having that full add-on profile support, which, pre-populates, logically named tags. There's no mapping needed to do. It eliminates all those IO mismatch errors, and it just streamlines everything in terms of programming and understanding what bit does what, because they're all named and it's very simple and structured for you to take advantage of. So we could have put this slide on every one of the products we're going to talk about. We chose not to. We think you kind of get this, but we will mention it as we go through because this is a key value of utilizing Rockwell integrated safety products with Rockwell controllers, similar to any Rockwell device with a Rockwell controller, be it safety or not. These full add-on profiles are a huge benefit and really do simplify the not only the initial build and installation implementation, but over time, greatly simplify any troubleshooting, any additional capability, retrofits, et cetera. So definitely something to key in on. So shifting gears a little bit to the next product. We talked yesterday about these 450L light curtains being a transceiver design, a patented universal transceiver, right? So each stick is the same, whether it's the right or the left, or the transmitter or receiver, whatever you want to say. Whether it's a transmitter or receiver is really dictated by the plug-in module that we plug in to the light curtain. Again, available in two different versions, either a basic version or an enhanced version. Basic being simple on off, enhanced being supporting muting, blanking, reduced resolution, etc. And the advanced also having a laser alignment feature built in. But the win here that we're talking about today is those same curtains, regardless of whether they're 450LB, the basic, or the 50LE enhanced versions. Either one of those sets of curtains in any of the lengths from 6 inches to 6 feet can be turned into a intelligent curtain over Ethernet IP SIP safety. So effectively what we have there is we have a plug-in module that allows us to bring Ethernet into the light curtain. So the Ethernet portion is the receiver. We will use the standard transmitter, but the Ethernet portion comes in as the receiver. And as you see, there's a little box that plug in the transmitter receiver and the two Ethernet connections, one in and one out, and then a power connection. And that creates our Ethernet IP safety light curtain, or SIP safety over Ethernet IP. So this allows us a couple of things, right? It allows us to have future-proof in designs, right? Even if we have a machine today that we feel we may go to integrated safety tomorrow, it gives us the ability to do that without significantly changing the setup and or any products that are on the machine with respect to light curtains. The other thing that it allows us to do is that it allows us to retrofit existing equipment, perhaps, right? So it gives us a lot of capabilities right out of the gate to do great things with respect to integrated safety. And again, simplifying the wiring and configuration. You're not wiring anything anymore. You're literally plugging in those connectors and managing everything in software, right? So again, that full add-on profile support that we just talked about with the MAB, you get additional diagnostic capabilities. You can get individual beam status. You can get all kinds of static and diagnostic information that you can pull over the network. You can do all the configuration in the add-on profile. So no separate software required to do any of the setup for the curtains. That can all be done in the add-on profile within Studio 5000 Logix Designer. And DLR capability we talked about, where you can go in and out with Ethernet, and you can get SIL3 PLE safety functions over that connection. Again, the highest level of safety that we have. All right, oops, wrong one. There it is. So shifting gears again, but staying with optical products. We talked yesterday, or did I say yesterday? I keep saying that. We talked last time about safety scanners and the value that they bring with respect to intelligent safety. And this one here, I'm saying coming spring. It should be next month, but we like to give it a little bigger window. So we'll say coming in the spring, is the advanced laser scanner over SIP safety Ethernet IP. And as you see, that's a slightly different color. It's actually a different laser technology. Just as a reminder how these lasers work, there's a laser that is effectively spun around with a little rotating mechanism inside that top of the laser scanner. And we sweep that laser across and send out time of flight signals, basically encoded, if you will, beams of light that then we receive, and we know how long it took to go out and come back. We know how far away the object is that it bounced off of. And we can go into software and configure, as you see down here on the left, we can configure different cell structures or different safe zones, if you will. The red is the safe zone. And the yellow is a warning field, right? So you have the safety field, safety zone, and you have a warning field or warning zone. And you can program that to be whatever you want it to be. You can work around different structures that are in the plant, et cetera. Like right here, this pole, right? We just say, okay, we're just gonna draw a line around that. And these, by the nature of their technology, are limited to a performance level D, by the way, which you see up here in the top. That is a limitation of the technology itself, not of any version that in particular. That's something in the standards that limits this to a SIL2 PLD, which is a very common, by the way, a very common performance level SIL requirement. So this new CIP-Safety over Ethernet laser scanner called SafeZone 3 is a next generation version of the existing technology. So it is a enhanced version that has higher definition distance measurement. So we get more pulses per scan, and therefore we can have a much better distance measurement capability. We can also perform better in dusty or dirty environments. As you might imagine, lasers in dusty or dirty environments, it's not generally something we think of as a good marriage. But in the case of that kind of dust and dirt that's not extensive, but maybe in the past has been problematic for this technology, the high definition distance measurement scanning technology can withstand much more of that. Again, all the add-on profile support we were talking about, configuration within Studio 5000 Logix Designer, the faceplate support. I think we might not have touched on that, but all of these products have the availability of faceplates, and faceplates are kind of pre-configured screens for our visualization products that allow you to pop those in and use them, as opposed to creating your own. A great opportunity to simplify, streamline your build and design time and cycles. Again, DLR, you're going to see that consistent across every one of these products, where we can come in and out with Ethernet to do linear or device level ring implementations, as opposed to that star configuration that would need a switch. And again, it's an enhanced version, right? So we have more features. You can have up to 8 configurable fields with 8 monitoring cases. You can monitor 4 of those simultaneously. You know, a 5.5 meter safety field, 275 degree of resolution, which is industry leading for this set of products. Okay. And the next input device we'll talk about is this 843ES Ethernet CIP-Safety Encoder. This encoder is extremely powerful. We can do advanced safe stop functions, if you will. We can do 5 different safe stop functions, 3 safe monitoring functions, monitoring being position, direction, right? And we'll talk about those a little more as we go. But a number of different configurations and mechanical configurations for different application spaces. But again, full add-on profile support, everything you need to get a safety signal directly into Ethernet IP with respect to an encoder. So what this allows us to do, if you think about encoders, I mean, we've been thinking about encoders for many, many years, is having, you know, the AA not, BB not, ZZ not, perhaps, right? And this basically simplifies all that by just putting it right on the network. This representation here showcases a solution that literally has no hard wiring other than you know, the power leads, if you will, to the motor. Everything else is literally connectorized. So we have a GuardLogix processor that is on a CIP-Safety connection, CIP-Safety Ethernet connection to a 527 drive, which supports CIP-Safety over Ethernet safe torque off. We have the MAB that we talked about, the multifunction access box, and we actually have an enabling switch plugged into that, which allows us to go inside the cell and maintain a safety. And then we have the CIP-Safety Encoder also on Ethernet, and then looped right back to the processor. So all that is Ethernet connected, streamlining wiring, streamlining capabilities, providing everything in one software platform, configuration, data, diagnostics, etc., all over CIP-Safety Ethernet IP. And what that encoder can do when it's sitting in there is it can do a number of different things, right? It can do safe stops, safe stop 1, safe stop 2. It'll do a safe operating stop, safe limited speed, safe limited position, safe direction. All those functions that are also available in some of our output devices that we're going to touch on. This encoder uses those same TÜV certified safety instructions within the processor. A note here is the 843 ES does need to utilize the latest controller family, which is the 80 family, right? 5380, 5580. So we're going to talk about that next, actually. So the latest family of GuardLogix controllers. This will be at a very high level. Just wanted to give some visibility to the latest in the case that you may not have become aware of this. We've had the 5370 safety controllers out for quite some time now, but the 5380, I am going to say maybe a year or two old, depending on model. But the 5380 is the latest version of our GuardLogix controllers with compact GuardLogix, the 5380s. As you're reading here, gigabit embedded Ethernet ports, so you get much higher speeds, and they actually have higher memory capabilities and such. So just the more advanced processor, if you will. And that, again, that Ethernet encoder, CIP-Safety Ethernet encoder, does require the newest, latest current controller to operate. Okay. And similarly to the compact GuardLogix, there is a standard GuardLogix platform, whereas the 5570 again has been out for a little bit of time, and the 5580 is the newest, latest, greatest version. Very similar discussion, higher speeds, gigabit ports, same kind of solution set. One thing to note on the 5570, you would always need a safety partner. You always had to have the main processor and the logic safety partner. So you had two modules, if you will. With the 5580, some of that 3Ds of safety that we talked about is actually embedded in the standard safety processor. So for PLD applications, you do not need that safety partner. If you need PLE requirements, then you do need that safety partner. And just to kind of give a little more on how we pull together a system, we're going to need I/O, right? So the I/O safety I/O platforms are listed here to give you a sense of that. We do have chassis-based safety I/O in the 5580 controllers, as well as the 5069 I/O, which is the I/O for the backplane of the compact Logix. So we do have chassis-based I/O for compact Logix as well in the newest platform, but that chassis-based I/O can also be coupled with a Ethernet CIP-Safety or Ethernet adapter. Actually, it doesn't even have to be CIP-Safety. That'll allow those safety modules to be used as remote I/O in a rack, in cabinet rack, remote I/O rack. We do have a Flex 5000 I/O module that's also safety. And by the way, the 5069 that we just talked about, which is effectively those same as those chassis-based models there for the compact Logix, as well as the Flex 5000, those both do require to be used with the latest processors. Again, the high-speed processors or high-speed I/O, they need the high-speed processor. The Point I/O platform also is a great solution. Still very, very common in many applications. And then, of course, we have our Armor Block I/O for direct on-machine mount. Just one more thing to mention on Point I/O, Flex I/O, Flex 5000 I/O, and the 5069 products. All three of those can mix and match safety and standard I/O on the same platform, if you will. So sliding into output devices, just a quick overview of output devices with direct integrated CIP-Safety capability. We have two AC drive products and 2 motion products that we'll highlight. The 527, as you see, component class AC drive, it actually utilizes motion commands. So it has that same look and feel as a servo, but it has integrated safe torque off over CIP safety over Ethernet. So no hardwiring of safe torque off required. And then the 755/755T, there are configuration boards that can be placed into those drives. One is called the S4 board. The S4 board allows you to manage that drive directly over CIP safety over Ethernet. So all the capabilities of that architecture class drive, all captured on CIP safety over Ethernet. And the Kinetics families, 5700, 5500, similar story there. ERS4 board, I believe it's called, with the motion products. But again, allowing us to get integrated motion, integrated safety all over CIP safety over Ethernet IP. And all these products, or actually not the 527, but 755, 755T, as well as the Kinetics families, can utilize those same motion instructions, motion safety instructions, if you will, that we discussed with the encoder. And you actually can add one more, which is the safe brake control. So that is something that the drives can do. The encoder obviously doesn't have the brake, right? But similar to what we were describing, we can do very advanced safety functionality all over CIP safety over the Ethernet to these with these products. So that's our walk through the product set, latest and greatest set of products that allow us to use fully integrated safety. The next kind of topic here we want to touch on is the tools that allow us to implement these solutions and these sets and make our applications come to life. So first thing is the Safety Lifecycle Toolkit, because as we've discussed, the safety lifecycle is critical. This ensuring we have safety as the first step is the most critical piece. So the Safety Lifecycle Toolkit is in the ProposalWorks set of products, product selection toolbox set of products that allows you to access everything in one place. So from here, you can access the RASWIN risk assessment software, if that's something you're interested in. The Safety Automation Builder, which ties into Systema. And although Systema is, again, as we mentioned in the last session, not a Rockwell tool, we do provide the link within our tool so that it can be utilized easily. And pulling everything together in one place for you to be able to go into the Lifecycle Toolkit and get what you need for your applications. One of the best kept secrets, if you will, hopefully it's not a secret, but one of the best resources out there for implementing these safety solutions is these safety function documents. And these, again, as we stated on the last call, really do give you everything you need to implement that safety function. Gives you that functional description, gives you the setup, the wiring diagrams, bills of materials, any kind of configuration or settings, all the appropriate function safety, TUV certified safety function blocks and such in the software. It ties you right into exactly which ones to use, how to use them, gives you the verification validation plans, shows you the calculation of the performance level, etc. So I would highly, highly recommend that if you're involved in any safety development or any safety solutions, these safety function documents are by far, one of the best things out there for you to take advantage of. It makes things so much simpler and really lays out the path to success. And the other thing with respect to fully integrated safety, when you start looking at how do I program this? How do I work this into to safety programming? The sample code library is very good, and it allows you to grab a collection of sample code that is highly documented. There's also some faceplates AOI sets out there that we can take advantage of. And At one point in time, there was a DVD. There may still be some of those around. Not too many people have DVDs these days, but there was a Safety Accelerator Toolkit. But the pieces and parts that were in that toolkit are still available. They're just posted up on, again, the sample code site, and those safety function documents. Okay. And then the overall recommendation for safety, we always recommend to be familiar with the safety requirements, the standards, regulations, what we need to be doing to ensure that we do have a robust, safe solution set. And that's it. This Safebook 5 is a great resource to get going in that world if it's something you haven't stepped in, or something you just want to dig into a little deeper, a little further. This book is not a difficult read. It won't put you to sleep, at least not that quickly. It's actually done very well, but it captures all the things listed here, and application examples are particularly useful as well, I find, at the end. So a couple of closing thoughts. This whole philosophy about smart safety is really something that we need to move toward more and more. We need to drive that whole collaboration between standard and safety control, and whether that's on the simpler type of applications where we're just doing the information enablement or the information integration, or whether it's more complex or larger systems where we're really driving toward fully integrated safety solutions and getting those advanced functions that allow us to do things differently and safer than we have in the past. Those are things that we can really make a difference in terms of what's out there in equipment and designs. And really the devices is what makes that happen, right? Those smart safety devices, whether spanning from those, simple SensaGuard RFID type devices that have the intelligence in the switch, maintaining a much safer environment than any dry contact electromechanical switch ever would, or all the way up to fully integrated, servos with advanced safety capability. Those smart devices there and anywhere in between are really what's going to allow us to take advantage of different ways to do things and make a safer place to work and safer equipment in the field. And also driving productivity at the same time, which is a key element to what we're trying to achieve. And I would say just make sure we leverage those tools. Again, those safety functions, I would say, are the first place I would go. If you haven't experienced those, I would definitely say that it would be a great tool to leverage. And then follow that safety life cycle all the way through. Make sure that we're doing things the right way, and that the easy way is the safe way. We're designing those safety circuits such that is the case, and getting the safest situation we can out of the equipment that we're putting together out in the field. So with that, Andy, I think that's all I had. I'm not sure if you had any kind of capper there, but that's the end of what I had put together.
That was awesome. Thank you very much for that. Hopefully everyone learned something or got some knowledge out of this that would be helpful. With the Safety Book 5, HESCO does have stock of that. So if you are interested in obtaining one of those, just reach out to me. Angela will be sending out a questionnaire for the webinar we just had, and my contact information